Dear visitors, we are now in the Samara University's Museum of Aeronautics and Astronautics, named after Sergey Pavlovich Korolev. The museum was founded due to the rector Viktor Lukachev in 1975, and the museum was opened in 1977. Students and teachers of our university, as well as enterprises of the region and of the country, contributed to creation of this museum. One part of the museum is dedicated to the development of aviation in our country, and another part is about the development of cosmonautics. Our tour starts from the development of aviation. Here are the models of aircraft presented that marked the launch of aviation. The Wright brothers in America were the first men who created a flying machine that went to the sky in 1903. Here is a model of their plane. It looks like a bookcase. Actually, yes, they were engaged in the bicycle business. They had a workshop where they made bicycles. At the same time, they were very interested in flying and began to design vehicles that could fly. One of that models was successful, and in 1903 they launched it into the air. The entire world community recognizes their primacy, but the Wright brothers tried to keep their inventions in secret because they planned to patent them all, and they got a patent. Public flights of aviation began in France in 1906. Alberto Santos Dumont, who was born in Brazil, designed an airplane in a Paris countryside in 1906. This vehicle took off and flew 61.5 meters. The flight height was 3 to 4 meters, and then it landed. So, 1906 is considered to be the year of the beginning of the aviation development because public flights began and the use of aviation for civil purposes began too. The most successful aircraft designer in the beginning of the 20th century in Russia is considered to be Igor Sikorsky. It was in 1913 when he designed a four-engine aircraft Ilya Muromets. It was the world's largest aircraft at that time. It was used for transporting both cargo and passengers. And when the First World War began, it became a bomber. Here in this glass stand, the models of airplanes are presented that were produced by enterprises of the Samara city. In the 1930s, our city was quite provincial. Citizens were engaged mainly in agriculture. When the Second World War began, more than 40 factories were transported to Samara. The industrialization of the city increased 11 times. After that, Samara became an industrial center. The entire city was focused on construction and production of aircrafts. After the end of the World War II, the factories remained in the city. They were not evacuated back, and they continued to produce the aviation equipment. Our city produced military aircraft, jet fighters, bombers, as well as Tu-154 passenger aircraft and cruise missiles. From that time and by now, Samara remains aviation and space industry producer. The next part of the exhibition is devoted entirely to the development of aviation in Russia. There are many models of Russian aircrafts here. In the 1930s, aviation in the Soviet Union developed very fast. The USSR held the leading positions in the field of aviation development at that time, but there were pros and cons. There were very good design bureaus, but the engine construction and radio engineering were behind in development. Nevertheless, a lot of smart aircrafts were built to set world records. For instance, there is a model of the plane N-25 with red wings. This is the plane that was built in 1937 and took Baidukov, Belyakov and Chkalov on board from Russia to America across the North Pole directly without landing. This was a world record to fly 63 hours on a single engine plane. This, in fact, was a real achievement. Let's proceed with talking about the Second World War. During the war, Samara produced the most mass-produced aircraft of the Second World War, the Il-2 attack plane. Here is the model of this attack plane. During the war, more than 38,000 of these planes were produced. The aircraft is unique in its characteristics. It allows to solve serious tasks during combat operations. Here is the pilot's costume. These suits are worn by pilots who fly at supersonic speeds. Supersonic speed is a speed above 1,200 km per hour. This suit makes it easier for the pilot to bear the overloads that he experiences at such speeds, and also protects the pilot's body if the cabin pressure rises at high altitude. Let's move on and talk about the development of aviation in Russia in the post-war years. There were a lot of interesting developments here. Here is the model of the NK-12 engine developed by Nikolai Kuznetsov. Nikolai Dmitrievich Kuznetsov was the academic designer who lived in and worked in Samara, and this engine was created for military and civil aircraft. He applied a smart scheme of rotation of these screws. They rotate in the opposite directions, the so-called biaxial rotation scheme. The engine turned out to be quite good and has been used for a long time. The orange balloons displayed on this stand are flight emergency recorders, the so-called black boxes. They are previous modification. Now more modern, there are electronic blocks. Previously it was written on magnetic type or magnetic wire. According to modern requirements, the outer shell of such a black box must withstand a temperature of 1300 degrees for an hour. It is believed that if a disaster occurs, the kerosene will burn out within an hour, and it will be possible to obtain information, get data on why the disaster occurred. 2 boxes are usually placed on passenger planes, though sometimes 4 are installed to modern airplanes. Our museum possesses a catapult, the pilot's workplace. This is one of the first catapults. These catapults are put in combat aircraft, sometimes even used on helicopters. They save the lives of pilots if there is an accident or the plane is shot down. Here are locators or radars in the museum. They are called differently for different purposes. This is a locator for civil aircraft to detect storm clouds so that the aircraft doesn't get caught in a thunderstorm. There are locators for combat aircraft. They were designed to detect and destroy enemy targets. Let's see the heritage of Nikolai Kuznetsov. As mentioned earlier, this is the scientist, designer, academician who lived and worked in Samara city. He designed engines for aviation and space technology and also headed the Department of Engine Engineering at our university. There are aircraft guns that are 37 caliber guns. They are just museum pieces. They can't be used anymore because they are old and out of order. And these are the cameras. This one is aviation camera intended to reconnaissance and determine the occurrence of bombing. And here is the satellite camera. Such ones were put on satellites to photograph the Earth from space. Let's move on to space. There is a model of Vostok rocket in the center of the museum. This is the rocket in which the first cosmonaut of the planet, Yuri Gagarin, made his first flight in 1961. For our city, this rocket is notable for the fact that its first and second stages were manufactured at the Progress plant, which is a Samara's enterprise. This is the first stage consisting of 4 blocks. In the center is the second stage, and behind the bars is the third. Gagarin himself was placed into the lander. It is where the orange part is. And here is a very exciting exhibit. This is a real rocket engine NK-33, developed by Russian famous scientist Nikolai Kuznetsov. Characteristics of this engine are completely unique. In the 1990s, the USA government bought this engine and established it on its Antares missiles. It was designed for a first-stage rocket, but according to technical specifications, the first-stage engines should run for 200 seconds or maximum of 300 seconds, no longer required. When Americans began to conduct tests before buying, after a full-scale test, the engine had been working for about 1500 seconds. It means the engine is very reliable and descends when the rocket takes off. The Museum of Aviation and Cosmonauts is named after Sergey Korolev, as well as the university. And this stand is dedicated to the work of our chief construction, who invented missiles for space exploration and national defense. We have personal belongings of academician Sergey Korolev, a hat and a tie. And here is a very exciting exhibit. This is a real rocket engine NK-33 developed by Russian famous scientist Nikolai Kuznetsov. Characteristics of this engine are completely unique. In the 1990s, the USA government bought this engine and established it on its Antares missiles. It was designed for a first-stage rocket, but according to technical specifications, the first-stage engines should run for 200 seconds, or a maximum of 300 seconds, no longer required. When Americans began to conduct tests before buying, after a full-scale test, the engine had been working for about 1500 seconds. It means the engine is very reliable and descends when the rocket takes off. And here is another engine of the rocket, which was made for the museum purposes and for study purposes. This Museum of Aviation and Cosmonauts is named after Sergey Korolev as well as the university. And this stand is dedicated to the work of our chief constructor, who invented missiles for space exploration and national defense. We have personal belongings of academician Sergey Korolev, a hat and a tie. In the early 200s, Russian government intended to issue banknotes with the portrait of Korolev, but they changed their mind and only a test lot was issued. Here you can see notes written by the academician himself. In general, he began his career in the early 1930s. He was strongly engaged in aviation, in particular gliders and its design. In the mid-1930s, he got interested in rocket technology. In the late 1940s, after the World War II, the government assigned him to develop missiles primarily for the defense of the country, and in parallel, he was engaged in spacecraft construction. Korolev always dreamed to send a man into space. In 1955, he designed his famous R-7 rocket. Here is a model of this rocket. The rocket is two-stage, 4 blocks of the first stage and the second stage in the middle, and this rocket is famous for the fact that it took the first artificial satellite of the Earth into orbit on the 4th of October 1957. The satellite itself was quite small, weighed approximately 80 kilograms, and it had been in space for 60 days. Nevertheless, it was the first step of mankind into space. Next, we will talk about the space industry. It has been developing actively in recent years. In 1961, Yuri Gagarin was the first cosmonaut to go into space. This stand is dedicated to the Russian first cosmonauts who mastered the outer space. The second cosmonaut was German Titov, and Alexei Leonov was the first human who go out from the space station into the space. Here are samples of food consumed by astronauts on orbit. Everything is packed and divided. While in space, there are weightlessness, space radiation, and a lot more incomprehensible and unexplored issues. So, the presence of astronauts in weightlessness implies inventing certain conditions for life. So, all the food is packed, divided into parts to prevent them from flying in the air inside the cabin. Here at the top is a model of a lighting satellite, one of the first communication satellites. Such satellites are placed in a geocentric orbit, an orbit that reaches 40,000 kilometers at its apogee, and it rotates around the Earth along with the rotation of our planet. Its angular velocity is identical. Several of these satellites are hanging over the planet. They carry out communications throughout Russia, such as satellite TVs. Here is a stand that is dedicated to the development and engineering of various spacecrafts, which were also produced in Samara city. We have a unique exhibit, a descent capsule. In the late 1960s and early 1970s, there was a need for rapid delivery of information to Earth, but there were no radio channels that time. We came up with a scheme like an old cassette cameras. 2 or 4 such capsules with films were docked to the satellite. You can see it in this model satellite. This was a camera, and there were 2 or 4 capsules attached to it. This capsule is presented in full size. When the film was full with information, the capsule was shot back and parachuted to the designated place. Then it was picked up and the containing information was examined. Here on this stand is a spacesuit of an astronaut. This is one of the first developments of the late 1960s to early 1970s. These suits were used for flight safety. Cosmonauts got into a rocket in these suits, fly to the station, and when they arrive, they get suits off. Upon returning to Earth, the suits were put on again. Spacesuits of a heavier class with another design are used for spacewalks. Spacesuits are sewn to size, just like regular suits. Gloves are made individually for each cosmonaut. The fact is that they work in gloves, and the gloves must fit exactly on the hand so that they do not accidentally press the wrong button. This stand is dedicated to the activities of the space industry in Samara city. Here are models of satellites that were produced at the Progress plant. This is the Zenit spacecraft, famous for the first stereoscopic survey. The Photon spacecraft is a flying laboratory where there are several automated laboratories that conducted experiments in space. The scale is 1:15. This white peon is a real satellite developed by scientists of Samara University in 1989. 6 such satellites were launched into space, and the 7th remained on Earth. Next to it is a model satellite. While the peon used radio emission to study outer space, the model was tried to use laser stations, and a new satellite was conducted. Here you can see mirrors reflecting. Nearby is a model of a nanosatellite. Our designers are developing such satellites. Now, electronics allows us to develop very small satellites that solve big problems. It is planned to create an entire constellation of such satellites in orbit. The scale of the nanosatellite is 1:1. Under the ceiling there is a model of the Mir space station, the space station that was constructed in the USSR in 1985. In outer space, it flew for 16 years, and in 2001 it was brought down from orbit. The fact is that in 1998 the construction of another Mir space station began, the station that is currently on orbit, where cosmonauts and international crews work. In 1998, the first block of Zvezda station was also withdrawn. There are only two reasons why this station was decided to be taken out of orbit. The first is, of course, obsolescence and resource depletion. The second reason is the economical. Maintaining of two stations is quite expensive for the country's budget. Using this station as an example, you can understand how space stations are built. The central block of white and beige color, on which the word Mir is written, weighted about 20 tons. Its length is 13.5 meters. All blocks are placed separately into orbit by rockets, then it is connected to each other in turn in orbit. Inside, astronauts turn on the equipment, lay cables, and the station begins to work. Similar to the way we built LEGO on Earth, this is how space stations are built. The Green Progress spacecraft is a cargo ship that carries cargo, food, water, and oxygen to astronauts. The gray Soyuz in this spacecraft that carries astronauts. This is a model of the Soyuz launch vehicle. It is the rocket that is currently being produced at the Progress plant. Now the development of a new carrier Soyuz 5 is beginning, and you see here the Soyuz 2. The rocket turned out to be very reliable, one of the most reliable missiles in the world. It has 3 stages, 4 blocks of the first stage, the second stage. Behind is the grid is the center third stage. Here the payload is placed. Sometimes the 4th block of accelerators is placed also here to bring a group of satellites to a higher orbit. This rocket has a system for saving astronauts. There are special engines. If suddenly there is an accident at the start, this system is trigged and it takes the cosmonauts from the rocket and they descend by parachute. In October 2018, there was an accident. During the launch from the Baikonur Cosmodrome, the rocket crashed, but thankfully the rescue system worked and the cosmonauts were saved. There was an international crew, 1 Russian cosmonaut and 1 American cosmonaut. In March 2019, they managed to fly to the station to work. There are many more models in our museum. Welcome to our museum by yourself and see this exhibition. Goodbye.